This video is about linear inequalities and solving them. It's 2.7 in the book we're currently using. So you have a table here, inequalities and interval notation. If the inequality reads a less than or equal to x less than or equal to b in interval notation, we would want to have a bracket like that's kind of squared off there, a comma b, and then another squared off bracket. That means that the ends are included in that, and everything in between. Now we are including basically all real numbers for this, so that includes not just a and b. Be careful not to confuse it with a point, but it's everything in between and including them. And then graphing, you would just simply draw like a number line there with arrows, and you would have point A with a circle or a bracket and point B, and you would include everything in between there as well, so you can shade that in. Sometimes people write it kind of above as well. So this next one, this reads a is less than x less than b, so we're not including the a and b, so we're just going to put curved parentheses, a comma b in parentheses, and we will have again the number line, but we're going to have an open circle where a is and an open circle where b is, because we don't include them. Instead of the circle, you could put, if it's included, you could put brackets. If it's not included and you have open circles, you would have parentheses. So those mean the same thing. Sometimes you have one or the other is included. So why don't you go ahead and do the following two problems. A is less than or equal to x less than b. A is less than x less than or equal to b. You should have seen some interval notation and kind of number line graphing in the past. If you haven't, you might want to go a little more in depth with the extra help videos. There's a lot of resources for you to go through that with a finer tooth comb, but I think you'll probably pick it up even if you haven't seen it in a while or aren't familiar. It's not too technical. The one thing I do notice people making mistakes with is they would look at that a, b, and instead of taking that as a domain of something or an interval, they just look at it and see it as a coordinate pair, like a point for graphing. So you do have to make that distinction and know your context of the problem, as always. So go ahead and try the next couple, or try all of them if you want, and then I will, so pause the video and then I'll quickly run through them. Okay, so the next one will be a is less than or equal to x less than b. So we would have a closed bracket, a comma b, then with an open parenthesis, and then that one you would have a closed circle. The b, we're going to leave it open. The next one is pretty much the same. It's just that b is included this time. So we have a less than x less than or equal to b would be open parenthesis, a comma b, closed parenthesis, like with the squared off bracket. And the number line would have an open circle at a solid line up to a solid circle at b. Okay, the next one, we had a little typo that I just fixed. So we had x is greater than or equal to a. So that means we are going to be starting at a. So we put a bracket with a, comma, and then the infinity symbol is kind of like a sideways 8, close parenthesis, but we want that parenthesis to be a curved parenthesis, because we can never bound infinity. So then on our number line, we would have a closed dot at a, and then an arrow to the right going all the way, indicating all the way to infinity. The next few are pretty much the same, so just be careful what you include and don't include. So go ahead and try those few. X is greater than A, X is less than equal to A, X is less than A. And then try to figure out how you would indicate all real numbers using interval notation. So on this one here, X is less than or I guess, what did we leave out on? X is greater than A, so we have parentheses, A, comma, infinity, parentheses that are curved. Both of those are curved. And then over here on the graph, I have an open circle at A and a line to the right with an arrow. The next one, X less than or equal to A, I have curved parentheses, negative infinity, comma A, and then squared off bracket to include the A. So on that one graph, number line off to the right, I'm going to have a closed circle and then an arrow indicating all the way to the left. The next one, X is less than A, then we would have a closed or curved parenthesis, negative infinity, comma A, and then a curved parenthesis again. And on our graph, we would have an open circle with a line and arrow to the left. All real numbers that we have right here, that is going to be negative infinity to positive infinity, and you're going to have curved brackets, and you would indicate on the number line that it would just, be totally full. Another way to write all real numbers, like in set notation, like right here where I have the words written out, this symbol is actually a double vertical lines, and then so it's like a capital R with double lines. Okay, now we're going to solve this inequality. Same solving process as if you're doing an equation, except that if you happen to divide or multiply by a negative, you need to reverse the inequality symbol. Also, if you end up with like your variable to the right and you switch it over to the left, you need to switch around the inequality symbol as well. So this one, you should know how to clear it. It's a fraction, so that's review. Just be careful of this symbol. You're just going to carry it down on this one until if you were to have a situation where you divide by a negative, but let's see what happens on this one. So you have x plus 2, and remember we want to put parentheses around numerators when we have expressions in them. The numerator is a grouping symbol, as is the denominator. So we have x plus 2 in parentheses, all divided by 3, minus 3/4 less than or equal to negative x over 6 plus 1. So I want you to try to clear that and start the problem and see how it goes. You should get x equals 13 over 6. So I'm going to put like try it, and then I'm going to put the answer x equals 13 over 6. So if you're getting that, you don't necessarily, you can skip through the video part, but do make sure you graph it properly, because what that means, it's actually not equal to 13 over 6, it's less than or equal. I should fix that. And the graph will look like, you're just going to place it, kind of estimate where it goes. It's kind of right in here. Okay, so we would put a solid dot and an arrow to the left. Okay, so it's going to be 2 and a 6, so you don't have to be perfect with that. So go ahead and try that one and see how it goes, and then we'll tackle the compound inequalities, or like sandwich ones, I like to think of them. Okay, so we clear the denominator by multiplying by the lowest common denominator. I think you guys are doing really well with that. So multiply by 12. Just make sure you distribute where you need to. Don't lose any of your negatives in there. So you might want to really even rewrite them like up here, like, you know, that's going to be negative plus a negative. Just switch it out. And then do your solving process. So we have 4x plus 8 minus 9 less than or equal to minus 2x plus 12. Don't forget to multiply by, 12 on the anything that's a whole number. I know that's common for people to forget. You can also like kind of put that over 1 so it looks like a fraction and you have to deal with it and you don't forget. Then we have 4x minus 1 less than or equal to negative 2x plus 12. And then simplify that down to 2x less than or equal to 13. And our final answer, like I said before, was x less than or equal to 13 over 2. And here's our graph. Okay, so this next one is what we call a compound inequality. So this is number 2, and it reads negative 12 less than 3x minus 6 less than or equal to 0. So there's a couple of different ways we could do this. We want to think of it as and. It's an intersection happening. You can split these apart and do them separately, but just know they're connected by the word and as an intersection. So you're going to get an interval between two numbers, not like off to infinity, like the prior problem. But what we can do is just work it. We're going to do the same process to each piece, and let's see how that goes. So if we know we need to get and focus on the middle here, we have 3x minus 6, and we need to isolate our variable term, the 3x. We want to add 6 to get that alone, get the 3x alone. So that means I have to do that to every segment. So then I'm going to end up with negative 12 plus 6 will give me a negative 6 less than 3x in the middle there, less than or equal to a positive 6. So it's kind of nice. You can just work it simultaneously. Then the next thing to do is focus again around that x term. So I have 3x. I need to divide that by 3 to get the x by itself. So I just need to multiply every segment by, divide every segment by 3. I'm just going to do the same action. So then I have negative 6 divided by 3. I get negative 2 less than x less than or equal to 6 divided by 3 is 2. So that is my answer in set notation, but I want you to write it in interval notation. So you can reference that chart up there. We have the first one is not included, so we're going to do a curved parenthesis, minus 2 or negative 2, comma, and then a positive 2, but then we're going to do a squared off bracket. And then when I graph it, I'm going to have an open circle at negative 2 and a closed one at positive 2. Or again, sometimes people use the parentheses or brackets for those as well. I'll write that above. So you could have a curved symbol at negative 2 and then the line segment with a kind of a squared off bracket at positive 2. Okay, so this next one is a little more complicated, but not, I wouldn't even say it's more complicated. It's just different because it has the word or in here. So this one is a union. So here, this one's an overlap. I have an intersection. Like if I had two circles, like that would be where they intersect. And I have the word and I'll put in there. And the symbol for that is an upside down U. Now this one for number 3 reads negative 7x plus 9 greater than negative 5 or x plus 9 greater than or equal to 14. And this we're going to represent as a union, which means we would have everything in both circles in included. So or in math means that it's and or, and sometimes there is no overlap at all, like what's gonna actually happen with this one. And we use the symbol U. It looks like a U, not really the letter U, it's a symbol, and that means or, and that's union. The other one up here is intersection for and. So this one I'm going to work kind of each side separately, but then I'm going to join them up with a union symbol there. And then I'll show you how to graph it. So the first one we have here is negative 7x plus 9 is greater than negative 5. So we're going to work that one down. So we're going to subtract 9 from both sides. We get negative 7x greater than negative 14. Now from there we're going to divide both sides by negative 7. So we have to be careful because we are going to need to reverse our inequality. So we're going to get x is greater than 2, but we actually can't have that. We're going to switch it around to be x is less than 2. I'll show you after in a little aside thing why we need to do that and how you can remember it. And then we're just going to put the union symbol here just to track it. The other side of the problem here reads, or x plus 9 greater than or equal to 14. So we're going to subtract 9 from both sides, and we end up with x greater than or equal to 5. Now be careful, I didn't multiply or divide by a negative, I just subtracted something that's different. I just leave it as is. So we're just going to bring that a little further down here. So now I have x is less than 2, union x is greater than or equal to 5. And so how I write that is negative infinity, comma 2, and I'm going to have curved parentheses around that, union, and then x is greater than or equal to 5, so I'm going to have a squared off bracket, 5 comma positive infinity, then end with a curved parenthesis. And I can write this, I'm just going to jot this down on my little number line off to the right, and I will have an open circle at 2 and a line all the way to the left with an arrow indicating it goes to infinity, negative infinity. And then the other one is a solid circle at 5 with a line and arrow off to the right indicating it goes to positive infinity. So that's a union. Sometimes they overlap, sometimes they don't. But you can see on this one how they are kind of separated. So one of the things I wanted to just point out is why we have to change the symbol when we divide or multiply by a negative. So I just want to point out, if I had something like 2 is less than 5, do you agree with that? I hope so. So we know that if we were to multiply or divide, I'll actually just do a little division. If I divided both sides by -1, for instance, just keep it simple, I would end up with -2 on the left-hand side and -5 on the right-hand side. And actually, that would not be true if I just carry down that less than symbol. I have to reverse it because I kind of, changed everything around. So I would want to change that symbol. So I would have -2 is greater than -5. I could also write it as -5 is less than -2. A lot of times we do left to right like that. So just that, remember that if you kind of get stuck and twisted up, like, when do I have to do that or not? That's just something concrete that you can remember to help you out. And let me know if you have any questions about that, if you haven't seen that before. All right, so I think that is it for this page. So in this video, it's a pretty short section. So practice up and be your chance to catch up on some things there. So have a great day.